Hi, I'll be talking about 5G coverage today. 5G coverage is evaluated by calculating the maximum allowed path loss, which is also known as MAPL on the radio interface, and we use a link budget tool for that. This tool estimates the achieved value of path loss over the planned environment. So here we are considering a mid-band 3.5 gig with certain considerations written on the bottom. This is for the uplink. We can have the similar thing for the downlink also, and on the downlink we are considering the transmitted antenna at 25 meters. We are seeing 23 dBm transmit power at the radio module, and we are considering a massive MIMO antenna of 128 antenna elements, so we get some gain of 21 dB. Then we have a beamforming gain. Sum up all the gains and losses at the transmitter end, we are getting 67 dBm as an effective isotropic radiated power, and this is then travel over the air to the UV. We are considering certain kind of margins. There we have to find out what kind of different margins we are considering. We are considering fading and the penetration margin here. On the receiver end, there is some kind of sensitivity you will be having and some kind of gain depending upon the antenna array they have. Now between this communication, we have to find out that what is the maximum allowed path loss to have or to sustain this communication, which will be a function of EIRP at the transmitter end, the margins, the sensitivity, and the receiver gain. So basis this calculation, we can find out the maximum allowed path loss. Here in this case is 130 dB for the eMBB services, and we have this calculation. We can go to 3GPP website. We can get different kind of calculations depending upon the different kind of frame structure, many other different considerations. Going back to the calculation, so this initial planning phase of cell radius is very important for the telcos. So cell radius is further a function of MAPL, base station height, and the frequency. If it's a lower frequency, we have a better or a higher cell radius. If it's a lower, if it is a higher, it will be lower cell radius. So for example, 3.5 gig will be having a less coverage as compared to that of 700 megahertz. Same calculation we can do for uplink in the similar way. I'll show you one example and how the coverage we can evaluate. I'm considering here an example of 3 sites. I've taken their lat longs. I've considered propagation model of close-in here, and we are considering the signal strength in a step size of 5 dBm. If I generate the coverage, we'll see how it will look like. It'll take a couple of seconds. So this will show us that with the different frequencies, what kind of cell radius we'll see. So here we'll see that as this blue color become darker, it is showing that how we are moving away from lower than 90, 100, 110, and 120 dBm. This is just one example. We can have similar case for other sites also.